All right, welcome back. Welcome back to part two of solving the scientific notation word problem. We're working on about the little doggy hairs fitting on that microscope. There's a lot involved, and if you don't understand scientific notation, you are going to struggle with this type of question. So I'm going to go over it. I'm going to show you how to convert standard form as just normal numbers into scientific notation. I'm going to go over another and give examples, and then I will show you how to convert scientific notation back into a standard form number. You need to know that in order to answer this type of question. After I finish going over those examples and understanding the rules, I will get into organizing the test question and go through with you step by step and understanding how to answer this particular word problem using scientific notation. So, hey, I'm just going to jump right on in here to it. And so, converting from standard form, that's just a normal number, into scientific notation. Now, I do want to say, let me back up a little bit. I've created an in-depth video with a few more examples, I should say, than what I'm going to go over today. So watch my video, both converting to scientific notation and then from scientific notation into standard form. Okay, check out my videos on that. All right. So first, in order to convert from a normal standard number into scientific notation, you must first move the decimal point until it shows a number that is between the value of 1 and 9.9. So we're creating a standard normal number, and we're going to create a scientific notation number, right? And that number has to be between 1.0 and 9.9. You're going to count that total number of movements. This will represent your exponential value. So this is what I'm talking about right here. Okay, if I'm going too fast, please stop, pause, and rewind the video. Watch it as many times as you like. So we're going to take this large number, 275,032, and we're going to convert that into a scientific notation number, which both equal values, just two different ways of writing it. I'm going to take the decimal point here. And I'm going to move this decimal point until I've created a number between 1 and 9.9. 1, 2, 3, 4, 5. I had to move that decimal point to the left 5 times to get 2.75. 2.7 is a number between 1 and 9.9. That's the rule. It has to be between 1 and 9.9. And I moved how many times? 5 times to the left. This is really important. This means something, okay? And so you can write your new value between 1 and 9.9 like you see here, 2.75. You don't need to include the 032. I'm just showing you for instructional purposes. And remember, the test question wants you to round up, excuse me, to the tens place. Pardon that interruption. So as we move the decimal 5 times, 1, 2, 3, 4, 5 times to the left, it ends up here between 2.7, which is a number between 1 and 9.9. Now we're just going to add that times 10. And when you move that decimal to the left, it's a positive value. How many times did you move it? You moved it 5 times. So I'm converting from a standard number into scientific notation. The rule is you move that decimal to the left, it's a positive value. Now, if we would have moved that decimal to the right, it would have been a negative exponential value, the number of times we moved it. And I've got that type of example I'll show you in a moment. So of course, you want to place that times 10, which makes that the scientific notation, and to the right. So again, exponent values, if the decimal was moved to the left like we did, it's going to be a positive exponential value, the same number of times you moved it, right? We moved it 1, 2, 3, 4, 5 times to the left, positive 5. If we would, but here, let's just continue on. But if the decimal was moved to the right, then that would give you a negative value. So let's take a look at some examples, and we'll just keep on keeping on here. So I have some more examples here. And so let me get this set up. All right, there we go. Here it is. Here's an example. Again, we're converting from a standard number, 325,267,012, into scientific notation number, which again is that number times 10 value. All right, so again, the rules are you need to create a number between 1 and 9.9. And if you can see here, 1 and 9.9. I'm going to show that invisible decimal. Move it 1, 2, 3, 4, 5, 6, 7, 8 times to the left to get 3.2. Is 3.2 between 1.0 and 9.9? Absolutely is. So that's a number between 1 and 9.9. So in converting into scientific notation, that is the rule. You have to have this number that goes in front of the times 10 between 1 and 9.9. How many times did I move it? 1, 2, 3, 4, 5, 6, 7, 8 times to the left. So my exponential power is going to be 8 because I moved it to the left. It's going to be a negative 8 value. So I'm going to place that times 10 right next to my new value here. And it's because I moved it to the left, it'll be a negative 8. Again, I moved it 8 times to the left, negative 8. 3.2 or 3.25 times 10 to the negative 8 is my conversion of the 325 million number into scientific notation. 3.25 times 10 to the negative 8. Let's see here. I got another example. I'll show you here pretty quickly. 32,526. I want to show my invisible decimal. Move that decimal until this number becomes between 1 and 9.9. That's a 3.2. Showing you here 1, 2, 3, 4 times. I moved it 4 times to the left. That's the negative 4, right? When you move it to the left 4 times, it's a negative value. Moving that decimal until I get a value of between 1 and 9.9. 3.2 is between 1 and 9.9. I could write 3.25 times 10 to that negative 4 value. Alrighty, let's see another example here. Number 3, I'm just going to show you here. I'm running out of time, so I'm going to just show you. I've got this value, 3,252. I'm going to show that invisible decimal here. I have to move that decimal until I get a number between 1 and 9.9. 3.2 fits that criteria. How many times do I move it? 1, 2, 3 times. 3.25 is a number between 1 and 9.9. Now, how many times did I move it to the left? 3 times. So I have a negative 3 exponential value. I have my 3.25 value. You do not have to show the 2. You can just go 3.25 times 10 to the negative 3 value. Stick with me. I'd like to show you a few more examples of converting standard form numbers into scientific notation. This is a skill you need to know. And if you already are very familiar with all of this and you know scientific notation and this is just some review, it's good for you to review, of course. But if this is something you don't need to know, you can always fast forward or watch video part 5, part 6, part 7 in answering this particular word problem with scientific notation. Thank you for your time. Math is easy. Take it step by step.